All right, let's cut through the buzzwords. Welcome to this explainer. If you've been hearing terms like loop engineering and agentic harness everywhere lately, and you're wondering what they actually mean in practice, you are in the exact right place. We're going to look past the hype and uncover the actual technical infrastructure that powers real AI agents in production.
So let's kick things off with the million-dollar question. Why do so many AI agents completely fall apart the second they hit production? You know the story. A project looks absolutely flawless in a staged demo, but then bam, it just completely breaks down when real customers get a hold of it. Teams spend weeks, literally weeks, obsessing over making their agent's text sound perfectly human, and then the whole system just crashes because a database timed out. Why does that happen?
Well, the secret, and really the culprit behind those spectacular production failures, is that the AI model itself, it's actually only about 5% of the magic. Seriously. The other 95% is just, well, it's the boring, deterministic, traditional software code that wraps around that model. That surrounding infrastructure, the harness and the loops, that's what actually determines if your AI is going to survive contact with real-world traffic.
Here's what we're covering in today's explainer. First, the 3 AI eras. Second, we'll meet the Agentic Harness. Third, we'll dive inside the programmatic loop. Fourth, we'll talk context and verification. And finally, the Mint framework approach.
All right, part 1, the 3 AI eras.
To really get a grip on where we are now, we kind of have to look back at how AI development has evolved. Think of it in 3 eras. Back in Era 1, the holy grail was prompt engineering. We were obsessing over the exact wording of a prompt because the models were, frankly, pretty rigid. Then the models got smarter, and we moved into Era 2, which was context engineering, meticulously curating exactly what data we stuffed into the context window. But today we've arrived at Era 3. Loop engineering. This is the era of designing the actual cycle where the agent is smart enough to pull its own data.
And here's the huge shift. Because these models can now write their own prompts and grab their own data using tools, the input is just no longer the bottleneck. It's a massive change. The scarce skill isn't feeding the model anymore. It's actually designing the environment that the model operates inside. You're deciding what it does between steps, how it checks its own work, and crucially, what happens when a step fails.
Moving on to part 2, meet the Agentic Harness. This brings us right to the core infrastructure that makes this whole new era possible. Let's borrow Simon Willison's definition here. An AI agent is not just a glorified chatbot. Think of it as a large language model that is equipped with specific tools or functions, and it operates within a programmatic loop to reach a targeted goal. It's an active, relentless system that just keeps running until it succeeds.
So, what turns that standard LLM into this active agent? That would be the Agentic Harness. This is the surrounding infrastructure, the vital code wrapping the model. It handles 3 critical jobs. Number 1, tool access. It gives the model functions to reach out and grab external data. Number 2, programmatic loops. It runs the model continuously to figure out the next step. And number 3, goal evaluation. It acts as an oversight layer, constantly checking in to ask, hey, did we actually complete the goal we were assigned?
This harness is a total game changer. It shifts the LLM from being just a passive autocomplete text generator into an active tool user. Instead of just spitting out a single response, you get this iterative execution where the model is the engine of a much larger system. Plus, developers can now decouple this underlying logic from the user interface. That separation is brilliant. It gives you interaction independence, meaning the exact same harness controlling your model's logic could power a consumer-facing chat window or run completely behind the scenes in a headless back-end system.
Okay, part 3, inside the programmatic loop.
Let's make this concrete. Imagine a customer support agent trying to process a refund. This step-by-step loop perfectly illustrates the React primitive. Reason, act, observe, repeat. A customer message comes in. The harness forces the model to act by classifying what the customer wants. Then it observes the result by, say, using an order lookup tool. Next, it verifies that data against the company refund policy. Every single step feeds into the next one. But if a tool times out and you didn't write the deterministic code to handle that error, boom, the loop stalls out and the whole agent fails.
And that brings us to the biggest danger here. Honestly, it's the single most common failure in loop engineering. Runaway loops with 0 stopping conditions. If you don't explicitly tell the loop when to stop, your agent will literally just keep calling tools, re-reasoning, and spinning its wheels on a task it can't figure out. It's just going to burn right through your token budget without ever solving the customer's problem.
So how do we stop the madness? You have to build explicit termination conditions right into your harness. And in a real production environment, you probably want a few of these running at the same time.
You might set a hard cap on the number of iterations or cut it off when a cost budget is exhausted. You absolutely cannot just trust the model's own sense of when it thinks it's finished. You need these hard boundaries.
Think of loop iterations like a strict financial budget. Every single time that loop turns, it is a full, expensive model call, which means your latency and your costs are scaling directly with how long that loop runs. If your agent takes 10 steps to do a simple 2-step task, well, you just got hit with 10 times the inference bill. You have to design the tightest possible loop that can still reliably get the job done.
Part 4. Context, verification, and decoupling. Beyond just knowing when to stop, we have to manage what the loop actually remembers. As an agent iterates, every new observation gets shoved into the context window. If you just recklessly dump every massive tool result back into the prompt, your model is going to suffer from context rot, and the quality will plummet. To beat this, developers use compaction, like summarizing earlier steps, or they write to external memory stores, or filter the tool results strictly. Sometimes, just spinning off a totally separate sub-agent is the best way to keep your main loop's context lean and focused.
Now let's talk verification, because this is the hinge the whole system turns on. There's this rule from Andrew NG that I absolutely love. Whenever you have a cheap, reliable verifier, put it inside the loop. It makes so much sense. If you can easily write deterministic code to check the model's work, like a simple script ensuring a refund isn't over $100, that check belongs directly inside your Agentic Harness. The agent drafts a response, the automated verifier checks the policy, and boom, the loop catches its own mistake.
And this is where decoupling your harness really shines. Let the automated loop handle the cheap, objective stuff, like those hard policy rules. But when a decision is expensive, highly subjective, or just completely novel, like assessing the tone of an angry email or deciding on a weird, out-of-policy refund, that is exactly where you route the task out to a human. The humans aren't being replaced, they're just being moved to where their judgment actually matters.
Finally, Part 5, the Mint Framework Approach.
So, how in the world do we actually build all this without the system collapsing into a total mess? Enter the Mint framework. Minimal intelligence necessary tools. This approach forces you to build the minimum viable system first, end to end. You start with just a basic prompt. Once that actually works, okay, add tool use. Then add continuous evaluations, then memory. You only add fancy multi-agent orchestration when there's a proven, observable need for it. If you try to bolt on 6 complex layers on day 1, you are never going to figure out which layer is breaking.
And as you're building, keep Andrew NG's concept of 3 nested loops in the back of your mind. They all run at different speeds. You've got your fast agentic coding loop, iterating in literal seconds. Then there's the developer feedback loop, where you're steering and refining the code over a few hours. And finally, you have the slow external feedback loop, driven by real customers over weeks. That last one is what actually tells you if your agent survives out there in the wild.
When you build incrementally like this, something really cool happens. You start naturally seeing Eng's 4 famous agentic design patterns emerge. They stop being just abstract theories and become literal functional building blocks inside your harness. Reflection? That's just your verifier checking the policy. Tool use is your order lookup script. Planning is how you sequence the intent. And multi-agent collaboration is just cleanly handing off subtasks to other specialized loops. I'll leave you with this thought to chew on as you start building your own systems. We know the AI model is just this unpredictable, non-deterministic engine. But have you spent enough time engineering the boring, deterministic harness that keeps that engine from crashing into a wall? It's time to stop obsessing over just the model itself and start engineering the loop. Thanks so much for tuning into this explainer, and have fun building.